Hey, everyone, and welcome back to Innovation Unplugged, the podcast where we meet with the innovators reshaping industries through breakthrough technologies. I'm Jim Brismitzis, your host today, and we're diving into the future of embedded systems, IoT, and edge intelligence with Embeint. In a world where data needs to be captured, processed, and acted on upon closest to where it's being created, Embeint is building the solutions that power the intelligent edge. From down under, might I say. From industrial IoT smart cities, they're enabling next generation capabilities at the device level and beyond. If you're curious about how intelligence is moving from the cloud to the edge and transforming entire industries in the process, well, you're in for a treat for today. And with that, let's get unplugged. Welcome, Phil Valencia. We're thrilled to have you today, my friend, and thank you for calling in from sunny Australia. We appreciate it.
Yeah, g'day. I have to do the obligatory g'day from Australia.
Absolutely.
Yeah.
Well, let's start with what was the inspiration, the backstory for Embeint, my friend? What were the problems that you were all trying to solve? In a world where, just as context, IoT has been around for a while with some intermediate success in some areas and maybe not so much in others. And I think that would probably be one of the first questions listeners listening in today probably have.
Yeah, well, it's definitely had a hype cycle, that's for sure. But I think we're coming into that growth of enlightenment. But my history has been quite a long one with the CSIRO, which is a national research organisation in Australia. And I was there for 23 years. And I guess for your audience, CSIRO is Australia's largest research body. It's a bit of a combination of sort of NSF and NOAA and even NASA and DOE. So it's all combined into this one sort of entity. And during that 23 years, I deployed and created just hundreds of different IoT solutions. We didn't call that back then. We called them sort of like wireless sensor networks and other things. But you know, it was fantastic. Like it took me all around the world. We solved some great, biodiversity things in the Amazon jungle and elephant deterrence in Gabon to reduce human-elephant conflict. All around Australia with tracking of bats and feral animals and on construction sites and even in the US in aerospace manufacturing sort of safety. And even to medical devices and stuff like that for human health. And it was like there was all these different things that IoT could enable. And in the last 7 years, I had a team with me that was helping sort of to create these solutions for all these different things, because we're essentially ahead of the curve, unlocking value of what IoT can do in these things, as sort of pretty much research projects. And we got a sense, in the last few years that there was still lacking that mechanism of getting those solutions to commercial, product and commercial, markets, and so that's where just over a year ago, we exited. So myself and three other co-founders of Embeint, and we set out to make a commercially supported IoT stack, or middleware, like oldies like you and I can,
Totally right.
Refer to. So it's essentially this embedded stack through to the cloud, and it's that that's often reinvented every time. And we figured that we had to reinvent it ourselves so many times for so many different solutions, and I guess that frustrated us a lot. And so therefore we said, look, why don't we create this stack and really help people create these intelligent, ultra low power IoT solutions. And that's what we set out to do. And it's been just over a year now. Yeah.
Okay. On that note, and I think this might come up with some of our listeners today, the big hyperscalers have had their own IoT stacks, arguably for the better part of a few years now, some of which have been retired. For those who are kind of thinking about, okay, so what's different about Embeint? Can you maybe just walk us through what is different? Like what are the specific stack challenges that you continue to see over and over again not being solved, ultimately hindering anyone who wanted to get into the world of intelligence on the edge from moving forward? So how would you sort of position what you've all done and created as value with Embeint versus what has been done in the past, or even
look, there's a great question that we inevitably always get asked, actually.
Right.
And the thing is that I was talking about that sort of slope of enlightenment, which is sort of the last part of the hype cycle where things are actually getting deployed and being used in production and making real value to the world. And I would argue that the edge IoT is already actually in that space, and your AWSs and other sort of services that allow you to deploy, say, a Raspberry Pi or similar class of computing device that's hooked into like USB power and has Wi-Fi or Ethernet or whatever, and is running some great AI on it. Maybe it's using a Jetson Nano or something like that, and it's doing some great value, right? And it's being delivered, and these systems are being used everywhere. And that ecosystem is quite actually well developed. And one sort of subtle thing is that under the hood, it's all using the great sort of TCP/IP that we all sort of know and love. And that's because there's not really a limit on the sort of packet structures and packet sizes that you can use. So it makes sense to use really well-defined protocols that hook into the cloud really nicely and easily, and and deliver those great IoT solutions. So I argue that's actually done and dusted now, and that's why these platforms exist. And we're starting to see like Qualcomm and others like that really pushing hard into the IoT sort of edge space. Right. However, the ambient IoT, and so I think they coined the word ambient IoT to sort of differentiate perhaps from standard edge IoT, because with ambient IoT, you're talking about devices now that are untethered, have to be ultra low power. They could be 1 million or more times less power consuming than, say, a Jetson Nano or a Raspberry Pi. Now, that's a lot, right? 1 million times less power, it is a massive constraint. And, these devices have to be lightweight, low cost. And in order to sort of meet all of that, they inevitably have to be very power efficient, and sending data all the time is not. And it's very, it takes a lot of energy to send, information out of these ultra low power systems. So in order to sort of solve that problem, what's happened is that these microcontrollers have become massively, exponentially more computational capable, and even starting to get, machine learning accelerators, et cetera, like that, available down on these like low power microcontrollers. And so it actually works out way better to bias the intelligence and the computation on these embedded devices, and then send the higher level sort of inferencing of what's happening when it's needed via the wireless, say, comms. And then that could be, there's all sorts of different LPWAN systems, which we can talk about. But, it's the right, horses for courses around which LPWAN, but it doesn't really matter. At the end of the day, they're all quite expensive in terms of energy with respect to how much you can compute on the device. And so this is where we see ambient IoT, the whole idea of always using TCP/IP starts to sort of fall away a little bit, and really lightweight protocols start to come sort of back, as a solution for what these systems need. Right. And that's where we play. So we play in these systems that often don't use TCP/IP because that two-way comms can be very expensive. So you want to go down to a system which is a bit more sort of broadcast, and then on the back of those broadcasts, or you have a connection down to configure the node or talk to it.
Right.
And and this is where our stack really sort of it digs deeper into the application than just say like the equivalent of the TCP/IP or a transport layer. We start enabling the drivers, whether it's the COM drivers or the low power accelerometer sensors or whatever it is, and how you go about scheduling those. So it's like a bit like of an operating system in a sense of firing up tasks and with different configurations and things like that. That all starts to become very important. And you can't use standard TCP/IP. And we saw a gap in the market around that, around having these out of the box ultra low power configured tools that allow the devices to be intelligent and behave intelligent, and schedule all their stuff, yet report to the cloud sort of in real time and compact and ultra low power sort of protocols to keep these devices sort of small and low cost. And that was the niche where we sort of realized that there's still a massive amount of reinvention happening there. And so there has been a lot of hype around ambient IoT, and I'd say we're still probably in the earlier stages of that, around what makes sense to, what comms and protocols and how to get the intelligence down to the device. That's all still being worked out, and then we see Embeint as being a platform for helping to solve that and stop reinvention of a lot of that.
Right. This is really interesting and fascinating, Philip. Thank you. Phil. Thank you for that insight. You mentioned also early on when you're introducing what Embeint does that IoT went through a hype cycle. And most new technologies, even AI, just recently has gone through and is now starting to come out of that disillusion into like real practical applications for AI. Why do you think now is different for IoT? And then two, there is so much data that even these low power intelligent devices can bring to whoever's buying and deploying, most notably enterprise clients that you've worked with. Why is that data so important to them now? So I'd love to get your perspective on both fronts.
I might start with the second one, which is that I think the data has always been important. It's just that it hasn't been practical or cost effective to be able to get it. So knowing where things are and how things are handled and how they're operating, if you could have that, infinite sort of God's eye view of how everything was going, you can optimize systems for better outcomes in, efficiency, productivity, and even safety, easily. But it's just been prohibitively hard, and the technology wasn't sort of really there, especially in the whole sort of, say, RFID sort of era, where there was lots of cost of infrastructure. If it missed it once, suddenly, that meant like it would completely stuff up the bookkeeping of everything, and then you'd add actually extra costs on to have to try to rectify that and try to find the box that was missing or whatever. The technologies of the microcontrollers being more performing yet lower power, and that's been a sort of exponential sort of growth. Yeah. You've seen improvements in the comms. It's almost been similar in terms of exponential growth with, in terms of bandwidth and yet still being able to, reduce energy, for those devices. We've seen improvements in battery tech and energy harvesting tech. And it's the confluence of all of those things that has, massively reduced the cost of creating these devices. And so we're at a point now where suddenly you can get this information that is now cheap to deploy. It's not as onerous in terms of the setup to get the systems deployed and getting that useful data out. And it's showing real returns for those companies that are deploying it. They can see the ROI almost straight away coming from these solutions that they're deploying because of how low cost, easy to deploy, and these systems are. So I think it's just that the time is right now with those technologies and how they've come along. Yeah. So that's why I think it's now rather than sort of 10 years ago when it just wasn't there in terms of the tech.
This is almost akin, Phil, to the early days of cloud, right? Many of the carriers around the world hosted colo services for data center operations and, called that cloud. It wasn't cloud, it was just colo. But it was a little too early for where the market opportunity was. And then, of course, obviously later down the road, cloud became what it is today, right? Which is initially infrastructure as a service and now much, much more than that. This is awesome. You're typically selling to enterprises, and it sounds like you're also selling direct into embedded device manufacturers too, those who want to be able to create turnkey. Where you can, is it possible maybe to share a couple of examples where Embeint today is being used. No disclosures of names if you don't want to, but just any sort of information, any sort of use cases where you have seen some deployments, and then the impact of that deployments for those users.
Yeah, sure. Look, our flagship customer is Ceres Tag, and they have a tag like this that there it is that sort of attaches to the cow ear, and it has a solar cell on there, and it's a great example of something that we were able to rapidly create the main application and secure ultra low power, but actually take logic as a binary of an algorithm from the CSIRO that has the animal behavior algorithm, and plonk that alongside the existing app on this device, and show that sort of marketplace of being able to have an app, the third-party app that's been developed, or algorithm in this case, and have it run alongside on this device. And what's amazing about that is that all of our customers who are IoT solution customers, we actually have two sides because we're building a market essentially. But the IoT solution providers like Ceres Tag, every one of their devices is a platform, like the iPhone, or Google Pixel is. It's not just a comms and sensing device. It's actually an avenue for having developers who are third-party developers unlock new value on these devices. And makes these things more saleable as well. And we see that for every one of our customers, whether it's in smart pallets or pet health or human health, in construction. Every one of those has this potential of the platform being able to run its main operating system and its main app that the IoT solution provider provides, but without them having to do anything. Have this developer ecosystem create new value unlocks for that industry and for those customers, and push them down like an app, like an app on an app store unlocks extra, stuff on your phone. So so that's the exciting stuff that we're doing there, and we're working with now numerous universities and research organizations who are keen on creating these apps for this Ceres Tag, and they don't need to see or the main application or anything like that. They focus on their value add, which is getting that data and training up the new algorithms for livestock behaviors and health and all sorts of other cool things. And they can focus on generating that value add, and then we offer a path to market actually for that algorithm being developed through to the Ceres ear tag. And it really excites me because when I was in the CSIRO, I was able to sort of see, not just with the CSIRO but other organizations and universities, the challenge of getting great IP like that out the door and into commercial. There's a lot of negotiations, and then once you've sort of handed that algorithm over to, say, a commercial company, they have to try to get their engineers to sort of bake it into the app, and there's all the extra testing and all sorts of stuff. And the marketplace just breaks that all apart and makes it so much easier to get these IP into these devices, and that's what really excites me. And so much so that for that particular deployment, we actually have our own SDK or development kit. So this is the Toro collars that Embeint sells, and we sell this to these developers because it's actually a development kit. Because if you want to create a new algorithm for a cow, in the field, from an ear tag, and you want, and this is the sort of the commercial, every animal gets one of these devices sort of thing. You don't get one of these on every animal; it's a bit cumbersome. But you still need that raw data. So you need that raw data on this ear tag logged, and to do it in a low power way that's actually on the animal out in the field, so you can get that real data to train on. What's cool is that this device Bluetooth pairs with this. That raw data is streamed across to this. This also logs a heap of cool data by itself. And those researchers and app developers are able to use that to create these new algorithms, and that we can then push through like an app store type model, push down to down to those devices. So so that's our sort of flagship area that we've gone into, which is into the ag tech area. But as I said, we've got customers who are using our stack in logistics and construction, pet health, human health, and others as well. And so every one of those also has other interested parties who want to develop new algorithms and apps for those platforms. So
totally,
yeah, it's quite exciting.
Totally. Without putting anything in your mouth, my friend, it sounds like AI, in addition to better, more low-powered, more affordable devices, plus better processing capabilities and such, that confluence of innovation, I guess, and progress in those technical areas has really made what you guys do so much more exciting today than it's ever been, right? And from that standpoint, and because you're the resident IoT expert, as these devices are getting smarter and more decentralized, what new trends are you seeing in IoT that may not be obvious to those who have been in that industry or in that space before?
So the AI, with IoT is something that's sort of a bit more of a newer area. And I think one of the things that we're starting to see is that there's definitely a push to push AI down to the edge. Like you see that with the iPhones and Siri running locally, doing stuff first, or even some devices that are maybe running a few layers of neural networks, etc., locally on the device before pushing sort of future feature vectors and stuff like that up to the cloud. And what I can see as a trend is more on-device processing, because rather than sending all this raw data to the cloud, which is great in some ways because you can train a lot of things and you can pull a lot of information out, but it also is quite expensive from an inferencing point of view. If you've got 1 million pallets that are all sending 100 hertz accelerometer data constantly to the cloud, that's a lot of data processing that's going on in the cloud. These devices can essentially run it for free and do that inferencing and still tell you exactly what you need to know about how this thing's being handled or if it's been dropped or whatever, and get that information up to the cloud, and then allow the cloud AI to use that higher level information then to make more inferencing across the whole deployment, rather than sort of trying to focus on an individual sort of sensory reading stream and trying to convert that and wasting a lot of power and a lot of computational cost, actually. So I think that is a trend that will definitely I see definitely continue. So there is that. There is this interim period of sometimes you do need to get that raw data in order to train those algorithms, which you can push down to the devices. And where Embeint helps with that, with our data logging and stuff that we offer, sort of neat ways of delay tolerant, sort of low power data logging. But one of the things that we foresee is this ability to sort of sporadically record this raw data and get snippets of it up to the cloud, train up new models, and actually push new models back down to the devices, rather than this previous history of IoT, which was sort of set and forget. You buy it, and whatever algorithms it had in it, you sort of were stuck with. We can see it moving towards a more personalized outcome where, algorithms can be periodically updated from the cloud, and even specifically to maybe your pet, right? So maybe your particular pet, scratches in a different way from other pets or whatever like that. And so you can send that annotation to the cloud, and then the system can say, okay, all right, for your pet, you need a slightly tweaked, machine learning model. So I'm going to send this new model down to you and get better accuracy and things like that. So I think we'll see more of that happen, and we'll definitely see more AI running across the whole system and pulling in extra information, federating data from other sources as well to make this high level stuff. That was something that I think, we missed when we first started Embeint was that, how powerful AI has become so quickly. in terms of being able to be thrown at the high level information and really make, useful enterprise-wide optimization, recommendations and things like that. And so we didn't initially focus on that. We focused in on, the embedded machine learning and how to get that down to the device, which is a good challenge and has to be solved. But I can definitely see a future of AI in the cloud where there's essentially like like another app store or development ecosystem where third parties are creating, AI agents that run across this wealth of IoT data, which is all coming out of tiny machine learning or tiny ML sort of algorithms up to the cloud. And then it's adding heaps of value for enterprises. And rather than a single enterprise having to try to, construct these AI algorithms themselves, these third parties can use all of their domain knowledge, et cetera, to unlock, new value as an app store. So that's something that we've just started thinking about around how we can help create that layer, which allows this new AI agents to run across data, federate data in, and yet still be third-partied in. And there's some other, there are already other entities, I think, out there, and some of them actually are alumni of the 5G Open Innovation Lab as well, which we're looking to work with to try to help enable that ecosystem.
Yep, it is an ecosystem, my friend, that is relatively fresh and ripe for huge opportunity. As you know, we've been on the AI side as a value add capability from carriers. You mentioned a lot of these machine learning models running on small devices, and kicking all that data up across 1 million of them to the cloud would just be an enormous amount of data. Even those little devices have its own limitations. And so what if you were to kick it up to an interim cloud, which could be a telco cloud, right? In your case, a Telstra cloud that could process some of that before you send the processed data up to the bigger models in the cloud. And that's an area that we'd love to continue involving you in as well. Actually.
Yeah. Look, I mean, we can definitely see that. So that's sort of almost like the in between solution between you've got your embedded ML, which can do some feature extraction and various stuff. You've got your edge ML, which can take actually a lot of the heavy lift of just sort of mundane repetitive stuff that, rather than pushing it all into the cloud, can actually be done low cost at the edge. And then that even higher level data and more aggregate information is then sent up to the cloud to do that next level of even higher level reasoning. And I absolutely see that. And one of the interesting sort of future research spaces that I see that maybe somebody will take on is the question around, can you dynamically work out where it's most efficient to run that ML and shift sort of the computational between those three layers dynamically? So I think that eventually that will come, but I think that's still a fair way away.
Yep. Well, it's good to see that IoT has made a comeback in a good way. It's never really gone away, because the value of IoT has always been there. It was just, I think, to your point, Phil, and you said it right. It was just too early in terms of market opportunity, and these different agendas from an technology standpoint weren't quite there, weren't quite mature. No. Now they are, and that is coming to a point where, okay, IoT is going to be much more important, certainly as more and more enterprises and device makers and such are looking to create differentiation through this valuable data. And I should say it'll be a combination of that edge AI and edge IoT, and Absolutely.
As well as the ambient IoT. There'll be 10 times or 100 times more ambient IoT devices than there will be edge IoT devices, and in some instances, they overlap in terms of their functionality of what they're trying to achieve. You can look at a table, at a restaurant via cameras, and work out whether, people are there or not, and when they get served. You can also do it via IoT devices, $1 tags that are sort of on the tables and chairs and whatever like that to work out, so you can solve it multiple ways. Totally. My point is, though, is that there are actually oftentimes where they're complementary. And so sometimes, the camera can't see it, and then sometimes the IoT devices can't really work out if it's a person moving it or something else or whatever, and these systems can actually work together. So, it's definitely coming. I think there's a lot of under the radar stuff happening right now, but there are millions of ambient IoT devices being deployed each year, and more than that. And it's really starting to come in. And before people know it, you'll start seeing sort of this intelligence embedded everywhere in our lives. And we'll just expect to be able to have that sort of knowledge and functionality for any object that we want at any time.
Yeah. Yeah. You won't see it. You won't see a sensor attached to my ear, but anything else, fine.
Not going to go Neuralink or something?
Yeah, maybe that. Absolutely. Yeah. Well, thanks, Phil, for a great conversation. And I think this is probably a good time for us to wrap up today's conversation with yourself and Embeint. Thank you again for sharing how embedded intelligence is advancing from behind the scenes to the forefront of innovation, and certainly how these technology patterns have emerged to a point where this is becoming not just a nice afterthought, but critical to both device makers and enterprises alike. For our listeners, if you're building or investing in the future of smart connected systems, Embeint is the company you'll want to follow closely. Please look them up. And be sure to subscribe to Innovation Unplugged, leave us a review, and share this episode with anyone who's curious about how the edge is becoming smarter, faster, and absolutely more powerful. Until next time, keep innovating and stay unplugged. And Phil, thank you again for offering your time to be on with us today.
See you. Bye.